sec. Okay, I think we're recording. So thank you to all of those that have joined us today. My name is Dominic Leone. I'm a software developer. I've been at Solution Street for just about 5 years now. I've worked on countless projects here, ranging from Ruby to Java, SQL Server, using Elasticsearch, working on in both small and large teams, maintaining legacy systems, as well as building new ones from the ground up. So today, I wanted to talk about, well, title here, Beyond Software Development, Becoming a Software Architect. Second here. So I wanted to start off with a quote from a gentleman named Martin Fowler, who's a software developer well known for his writings on software architecture and methodologies. So he says, the heart of thinking architecturally about software is to decide what is important, i.e. what is architectural, and then expend energy on keeping those architectural elements in good condition. Okay, so that sounds almost like a tautology, but just to explain it, I guess at its core, this is what the definition of software architecture, everyone seems to agree on, that software architecture is thinking about the structure of software and maintaining it. All right, so at a high level, I decided to research software architecture to give this presentation because at the beginning of the year, I myself wasn't sure what it meant to be a software architect. I knew that the next step along one pathway of a software career moves from a software developer to a software architect, and I wanted to make that leap. Again, not all paths lead to software architecture, but this is one I wanted to take that leap to. Quite frankly, I'm still not sure exactly what defines a software architect. I'm also not sure that anyone really is sure of what that means. There's so many different ways to define software architecture. So is a software architect someone that draws diagrams in Visio and writes up documentation? Is it someone that crafts a solution from the ground up in Visual Studio? Is it someone that determines how to orchestrate communication between services? Is it someone that leads a team of developers, right? So there's so many different ways we can define a software architect. Software architect doesn't have clearly defined roles because different organizations utilize architects differently. So instead of defining an architect, which I'll do a little bit here, I'd like to focus today more on the qualities that distinguish really an architect from your typical, let's say, junior to mid-level software developer. Now, notice I didn't say senior developer. There's a lot of skill overlap, quite frankly, between senior developers and architects. Excuse me one sec here. Sorry, I lost my place. And often we'll find some gray areas when defining the differences between architects and senior developers. In my experience, honestly, the main differences I found are just the title and the roles that an organization assigns to them. So really, at a high level, an architect is a technical leader who designs software according to a vision. So digging deeper, what this means is determining the tech stack, architectural patterns, clouds versus on-prem, estimating levels of effort using tools like diagrams, spreadsheets, and prototypes, translating business requirements into development tasks, expending energy on ensuring business needs are met, expending energy on maintaining a quality product, and communicating this vision and reasons behind the decisions. So how does an architect really differ from a software developer? So typically a software developer focuses primarily on code and spends less time with the stakeholders. So essentially, I guess an architect designs a vision, developer builds it. On the following slides, I'll talk about the required skills of a software architect, which set them apart from your standard software developers who can, quite frankly, sometimes skirt by without these specific qualities that I'm going to get into. All right. So communication, at least in my experience, communication is the most important skill of an architect. Software developers can often get by without speaking to anyone all day. Software architects rely on their communication skills to influence the final decisions of stakeholders and express their vision coherently to both the stakeholders and the developers. Right, so a software architect sells a vision. I think I've mentioned that a few times, but they really need to sell their vision. They need to convince the business and developers why certain solutions will fit the business needs better than others would. then in order to do so, they need to be able to express complex topics to different audiences, right? So pertaining to communication, a common language is important between developers and stakeholders. So this standardizes communication for requirements that both business and developers can read and understand. And I'm not going to touch on it, but I'm sure a lot of you folks are familiar with domain-driven design. It often helps model a more accurate domain that will be easier to extend and maintain. Okay, so here's where we get a little interactive. I'd love some feedback and just get some of your thoughts here. So looking at this diagram, who do we imagine this is for? Would this be something that you'd be showing, let's say, a stakeholder, like an executive maybe, or is this something that you'd be giving to the development team?
Developers.
Right. Yeah, I mean, again, there's no right or wrong answers here, but to me, this looks more for a developer. I mean, we're getting pretty low level here. We're talking about, okay, on a client, we're going to be using Vue.js. On the back end, we're going to be using a .NET Core solution, and we have a couple different tiers and layers here, and we're connecting to an Azure SQL database. Again, no wrong or right answers, but this seems more geared towards software development. If we look on this next slide, being that the first one was for developers, I'd imagine you can all guess that this one's probably more for stakeholders. Right, so this is a higher level diagram showing integration with, let's say, an identity management provider like Okta, where the user would have access to maybe a couple different applications. So here we're connecting to the Azure cloud. We have our services there. We can also connect to Tableau, but this is very high level. This is something that most stakeholders would probably rather see than the low level design here. All right. Any questions, any comments so far from anybody? Here. All right. In addition to being able to communicate effectively, an architect should know many different patterns along with the pros and cons. Software developers, on the other hand, should be able to follow patterns, but are not tasked with making important design decisions that would impact the software considerably. So an architect will often be tasked with building a new product or reimagining an existing system. All right, so a company relies on the software architect to build a system that will serve the business needs and not need to be rebuilt in n number of years. And architect needs to consider the business needs, consumers, dependencies, size of the team, extensibility, and many other factors. And here I just kind of listed a couple different architectural patterns. Now this is not an exhaustive list. There are so many more patterns, but I mean, these are, I'm sure most of us are familiar with. You have your all-in-one monolith, so like a Rails or a .NET MVC. You have your N layer / N tier monolith with, let's say, a .NET Core with your business layer, your data access layer, API projects, maybe with a separate UI code base. We could talk about microservices, so multiple front ends that are interfacing with, let's say, 20 different back-end services. So again, not an exhaustive list, but architects should have a general sense of many of these different patterns here and understanding in what situations they should be using them. So let's get interactive again. I'm going to give two examples here, and let's talk through this and just get a sense of maybe what patterns you would use. So if we look at this first one here, let's say we have a team of 5, maybe 4 junior, 1 senior. We have 1 month to build a proof of concept web application where users can post reviews of software consultants with likes, dislikes, comments, and ratings. Boy. After a month, the business will decide whether or not they want to dole out additional funding to build a more robust system. So what are we thinking here? What type of pattern do we think would sort of fit this here? And again, there's no wrong or right answers.
I would ask what the business hopes to learn from the prototype before I decide. Like, I don't think there's enough information to really make a decision.
Okay.
Monolith. We disagree.
All right, so here monolith, I hear we don't have enough information, and I'd say that both are correct. I mean, my thought when I wrote this question up was that we have 4 seniors. We don't really have an expert maybe with orchestration. We have 1 month to get something done. We want to get this done quick. Rails, right? If you have juniors, they're typically more familiar with Rails. Rails is pretty easy to get up and running, get a prototype out there. But again, like John mentioned, I mean, we don't necessarily know what we want to learn from this prototype. I mean, maybe we wanted to start with this prototype and build off of it. So maybe we would start with a different pattern. But given this information, I would probably say something like a Rails or a .NET MVC just to get something out the door in a month. Any other comments on this first one? Okay, let's move to the second one. So now we have a team of 20. We have a lot of senior developers with a strong DevOps engineer. So we've been tasked with building an API over a 1-year period that will interface with a mobile client. We have a web client. We have a few external services. The API is going to be for an ebook store for indie authors to sell their works with purchases, previews, refunds, reviews, uploads, and metrics. Now, what's important is that this system must be resilient, highly scalable with quick release cycles. So what are we thinking for this one?
Monolith.
Monolith, okay. Why are we saying monolith?
20 is too small still. You don't need to break it up. I don't know, 20 is borderline. I would probably go serverless. I wouldn't go microservice. I'd go serverless.
Okay. Yeah, I mean, that's an option. I originally thought microservices, but I mean, there's so many different patterns we can use. What I was thinking here was, I think what's important is that we have a strong DevOps engineer. We have someone that's going to be able to orchestrate everything. We have a lot of senior developers, so they'll know kind of the best patterns to put in there. Also, resilient, highly scalable with quick release cycles. So knowing microservices, we can deploy just chunks of the code. So if we need to just deploy, let's say, the refund module, we can do that without deploying the whole application. So this is something I would shy away from with a monolith and use something more like you mentioned, serverless, or doing some kind of microservice architecture. Any other comments here?
Well, it's a question, maybe you're going to get into it later, is, where does the role of the application architect and in the system architect begin? And does it, when you get into deployment architecture, if your initial diagrams are talking about software architecture, who's in charge of deployment architecture? Is it the application architect or the system architect?
Right. Unfortunately, I don't think that's something quite that I touch upon here, and that's a very good question. I'd have to think about that one a little bit, quite frankly, Joel.
Yeah, and then I think you talked about right there is there's a concept now of kind of DevOps architecture almost, or at least DevOps approach, or and it kind of gets into the what you were talking about, orchestration and automation, CI/CD, and so the the interesting question as we evolve is, who's in charge of that? Is there a DevOps architect, or is it the application architect? Is it the system architect, or is it one person wearing all 3 hats?
Yeah, and that's a tough question to answer. And I would say you'd probably get a different response from 20 different people.
Right.
But I think in general, a software architect would need to know these concepts and know whether or not that they're capable of making that decision, or whether they need to bring somebody in to help make those decisions. But you're right. If you don't have a strong DevOps engineer, you would never want to go towards something like microservices or a complicated orchestration framework.
This is Ed here. My question is if anyone on the call has experience, I'm just starting to use microservices for the first time, and my impression is that building for scale up front it's a question that should be asked, as whether it's worthwhile. So I don't. You can get a lot of scale out of a monolith and spending a lot of money on a single database server backend. I'm curious if anyone has any experience as to when, like, I don't know what the metric is, requests per second or something, when you start to see microservices shine. Like, I feel like you can get thousands of requests per second with a moderately horizontally scalable monolith, like 2 or 3 instances, all talking to the same backend database.
Oh, now I would agree, and I would say here that I think there's more concern with microservices than just performance. I think one of the big things is, let's say, quick release cycles, making it highly scalable, highly resilient. So microservice is more about performance, and it's less about performance. Well, it's also about performance, but it has a lot of other factors involved in there too. But yeah, I'd like to open the floor to see if anyone else has any comments.
Yeah, Jeff mentioned, I'd second it, is division of labor is the big thing with microservices.
Yeah.
If you have a team of 100 engineers, it's tough. It's tough partitioning a monolith up to have productive construction, like you're talking about. That's the big challenge. And for me, that's the bigger win. And I kind of, echo what Ed said. What we're seeing in the industry is backlash against microservices, because anytime anything's cool and new, people go and implement it even when there's no reason to. And so they end up trying to run those microservices in production, and they're not scalable, they're not resilient, they're not performant, because they're hard, they're complicated, And this idea that you can just release a component is something, it's a dream at least I've been chasing for 30 years. It's really hard, because you're always going to have downstream services that if they go out or they change, it's going to break, other services. So it's not as simple as just using a new architecture to solve, kind of a lifelong problem.
Yeah, good point. All right, any other comments before we move on here? All right, so let's get back into some of the qualities of a software architect. So software architects use a wide angle lens when viewing problems or features, whereas software developers keep typically more of a narrow focus, solving only the problem at hand. So architects are involved in design meetings with stakeholders, whereas developers are typically given requirements afterwards. Again, I'm not trying to generalize software development, right? So many software developers will in fact join in on design discussions or consider all of these bullet points I'm going to talk about in a second. But it's essentially the software architect's job to build a robust system and maintain good code quality. And these should always be kind of sitting at the forefront of their mind. So an architect needs to consider edge cases, scalability, infrastructure, security, level of effort, whether or not a bug is just a symptom of a larger issue, maintainability, resiliency, how certain tasks might evolve, usability, and probably thousands of other things that architects need to keep in the back of their mind when they're designing systems. So really, again, software developers might consider these too, but these sort of sit at the forefront of an architect's mind. All right, so focuses on long-term solutions. So earlier I noted that software developers fix problems. Architects have a different mindset. Rather than fixing problems, they want to focus on long-term solutions. So an architect's scope is much, much broader. They're always concerned with finding the optimal solution. So that means kind of extensible, scalable, performant, it's meeting the business needs. An architect understands the requirements and the problem before asking the team to code any kind of solution. So an architect is an expert at pulling out hidden requirements by thinking about what questions really they should be asking. All right, so here's another example. I'd love to get some feedback here. So let's say we have 3 teams working on the same monolithic application. They own different features, but they often find themselves dealing with merge conflicts, performance issues, deployment problems, which is slowing down development and time to production. So taking this approach from maybe 3 different viewpoints, how might a software developer approach this problem? How might a project manager? How might an architect? And I would argue that maybe the developer and the manager might have a similar mindset, whereas the architect might think a little differently. So let's just start with the project manager. So how do we think a project manager would attempt to fix these problems? And again, no wrong or right answers here.
Make some dashboard and have a bunch of coordination meetings.
Yes.
I mean, that's your classic PM approach to deal with something like this.
Yeah. I mean, my thought
Coordinate
was,
and talk about it more and it'll all get solved.
yes, I mean, so project manager is going to be concerned with the process. They're going to be concerned with maybe improving the sprint planning, maybe doling out the tasks a little differently, splitting them up better with no overlap. So they're more concerned with the process. So what would an architect think here, though?
I would want to know how dependent those features really are on each other, and if you need to be running on a shared core for those type of things, or if you could break those up in some way.
That's a fantastic answer. Yeah, I mean, the architect is more considered with the actual software design, and maybe a monolithic application wasn't the right choice here, or maybe things can be split up a little differently. But it seems like from an architect's point of view, there might be some sort of design flaw with the software. Any other comments on here on this? Yep. So just to recap, I think the project manager is more concerned with the process, where the architect is thinking more design. Great. All right, this is a quick slide here. So software will undoubtedly have bugs, right? So debugging is easy locally. Debugging in production is not so easy. So architects are tasked with building a robust system. So good logging is one thing that should always be considered. Good meaning kind of centralized and sufficient. So architects are always thinking ahead, wanting to put the software in the best position for success. And this is one example from my career here. So, and it's current, and we've actually fixed it a little bit, but there's still some improvements we can make. But we have, let's say, 10 servers with the same application for different clients. If we wanted to fetch logs for a specific client, we need to remote into a virtual machine, download the logs, and search in Notepad++. So why don't we just centralize these via Azure, AWS, Kibana, or some other solution where these logs are easily accessible and searchable? So software architects is thinking about how to make their jobs easier and how to make sure that the product is successful. Anyone have any other comments? Any of their own sort of stories here? Nope. All right. So
I think that's a pretty common one. Another one would be like the right level of logging. So, making sure there's a standard for your project so that not just that the logging is happening, but at the right level can be turned up to see the right type of problems, and making that standard across your project.
I think taking it even further is just providing a lot of context in the logs.
Yeah, useless log statements that give no data. Yeah.
Yeah.
And there's another strategy here too, which is if you find yourself going to production so much to look at logs, there's usually thought should be given to how easily can you pivot so that way you can recreate a problem that's occurring in production in a different environment, QA environment or local environment. Only have, if there's so many specific use cases that are happening only in production, then there's a way you can write a script to anonymize and grab a database and bring it down locally, so that way you can create the problem locally. As you mentioned here, a ton of users.
yeah,
I personally think logging is a problem that needs to be solved for I don't think it's solved yet for microservices. The project I'm working on now, I mean, hundreds of containers. I don't. There's no way you can present all that information in a useful format unless you make it searchable. And a lot of places I've worked at, it's expensive to index that much information, and typically their elk stack is an afterthought, and they're not willing to pump a lot of money into building the indexes and keeping it up to date and fast, so it becomes not very worthwhile. Something I've seen people moving towards is metrics. In other words, they don't have logs, just emit metrics, and emit metrics when there are errors, or time things is one of the other things to like measure how long it takes to do things, so that you can create alerts when stuff starts taking longer to kind of focus your search. But Yeah, I cannot break my old habits of SSHing into a server and just grepping log files. And I don't know. I hope someone solves this problem soon.
Sounds like you can make a lot of money at solving this problem. But yeah, I think those are some great things that should have been added to this slide, just metrics in general. And a couple other things that you know, Jeff mentioned and Joel had mentioned. So great points. All right. So as mentioned on the last slide, there are always going to be bugs, but an architect uses mistakes as learning moments to ensure that the same problem doesn't happen again. It's also very important to teach themselves and others. So here's one example that I ran into a couple months back. So our team had created a recursive algorithm to search Excel files for table. We had a Stack Overflow exception in production. All right, so great. Let me just switch it to an iterative approach. Okay, now I hit an out-of-memory exception in production. Okay, so we had to think a little smarter and put some sort of circuit breaker in there so we had no more issues. But I mean, this taught me, and again, I'm always learning. I'm sure all of us are always learning, but you always need to consider memory, right? And the other important thing is test on exceptional files. And this is something I struggle with all the time. You don't always focus on the happy path. So it's hard to think of all the edge cases. And as you grow in your career, you're going to get better at it. But it's hard to know all these different types of edge cases you're going to run into. But it's always important to have in the back of your mind. Don't always focus on the happy path. So this was just sort of one learning example, learning experience I had a couple months back that it's always in the back of my mind now. Anyone else have any comments here?
Yeah, I think that's good. I think the concurrency and security are two other that come to mind in that same sort of like, you know, what does the architect worry about? Like not just memory, but concurrency and then globally security, right?
Yeah.
I think.
Yeah, and I think I talked on that a couple slides back where, yeah, here an architect always needs to consider security. Doesn't mention anything about concurrency though, so that's a good point there.
Scalability kind of goes hand in hand with concurrency. Yeah.
But yeah, security is huge and should always be at the forefront of an architect's mind. Well, really at all developers' minds too.
But your point is mistakes on the same thing in security. Like, okay, we got hacked or we got penetrated. Let's not try to throw somebody on the bus. Let's try to figure out how it happened, why it happened, how we can prevent it from happening.
Yeah, great point. Anybody else? All right, so piggybacking off of the last slide, an architect teaches others, and I think this is extremely important. The architect takes the time to teach others, provides constructive feedback in one-on-one meetings and on PRs. And if you haven't seen it, I hope we have it on YouTube, but Prashant gave a great talk a couple years back on providing great feedback on PRs that I would definitely recommend seeing, watching, listening to. So here's one example I ran into a couple months back, actually. So on one project, we had issues with SQL Server performance on a few tables. After researching a while, I was rewriting queries to work around the problem, which solved it, but it didn't really solve the problem. I found that I needed to rebuild the statistics on a table with approximately 10 million records. The statistics were outdated. They were only reading out there were 8 million records in there, and thus it was generating inefficient query plans. So what I did here, I mean, not only did I read up on statistics and get super comfortable with them, but I made sure to spend time with the team talking about what these server statistics are and what to keep an eye out for in the future. Right, so it's not just about you learning things, it's about you teaching things to your team so that we can all grow as a team. All right, so any comments here? Any other stories?
So code reviews and code walkthroughs are a great example of also like using them as teaching moments, right? It's can you hear me? I don't know if you hear me.
Yeah, I can hear you a little low, Prashant.
Okay, no, I meant that I'm gonna try to project my voice. You know, we talk about code reviews, right? I think usually like that's like getting approval to get the code into, you know, the master branch or, you know, getting it approved for deployment. But like, for if a senior developer or an architect has, created something and getting the junior people involved and using that as like a teaching opportunity, to kind of go through some of these things. That's some of the patterns or just point things out. So
Yeah.
That's we're always looking at that as an opportunities to kind of distribute the knowledge and just raise the level of everybody on the team.
Yeah, great point.
One of my favorite new tools that I found, I mean, I'm trying to think of the generic term for this tool, I guess linters, but our build process has check style and sonar cube built in. And I used to hate those because I used to hate checking in code and then having it complain that there was white space at the end of my line and breaking the build. But now I love it because it really focuses reviews. Like, that any code that makes it into a branch, so we do merge requests, not pull requests. So if you commit a branch, you push it, the build server runs it. And if that build passes, then it's eligible to create a merge review. So by the time merge reviews are created, there's none of the nitpicky stuff that you can completely focus your review on well-linted code. And I think it's great because I think people want to be nice. So when I see reviews and I'm like, oh, I wish they would have indented this one more space, but I'll let it go this time. You don't have to worry about any of that. It's great. And you can focus your review strictly on patterns and implementation, things like that. It saves a lot of time.
Yeah, that's a great point. I mean, I've seen some great code, but it's just formatted so poorly that you're commenting on those, on just how you need to indent this, you need to do this, that it just, yeah, I agree.
So what I've also seen and experienced is that, an architect also sometimes needs to have a thick skin and be a bit of a dartboard, because especially around questions of linting and things like that, there's a lot of people with a lot of different opinions, but at some point there's got to be a decision made, and sometimes the decision made, you're not going to make everybody happy. And so an architect in that situation, assuming there's somebody involved in some of those decisions, needs to be able to justify any decisions that are made and explain them, and be a good, as you mentioned earlier, a good communicator with regard to those, to be able to talk to perhaps software developers who have different opinions, and not convince them, at least get them on their side to a certain extent.
Yeah, good point. Absolutely.
Yeah, I look at the architect as the ultimate person that's ultimately responsible for code quality. So they should be putting in the processes and tools, to Ed's point about linting and Jeff's point, to ensure that the project is not getting off base on quality. Unit test coverage, linting, precompile of things that need to be precompiled, compression of things that need to be compressed. So kind of putting in the tools and processes to ensure that quality across the board.
That's a fantastic point. Yeah.
One other thing, just to tie into what Jeff was saying, is explain the architectural decisions, but I think it's even more important to document them. So when new people come on the project, they realize, oh, we're using these tools, and here's why, or here's what the decision's been made, right? Let's not revisit it every time. I know we've done that on one project. We had an architect decision log, we call it, and it was helpful because new people would come on board and it would give us a reason. It would give us the way to explain why certain things were done in the project. You'll forget too. After a while, why do we decide to use this tool, or why do we decide not to use this tool? So I think documentation is huge on those kinds of things.
Yes, I would agree. I mean, I'm currently on a project where I am architecting the system, and I am documenting absolutely everything. And even while I'm documenting, it's helping me look back on some of the notes and then adjusting some of my decisions while reading through the documentation. So I've spent a lot of time in Visio and Microsoft Word, just putting together, and like spreadsheets too, just putting together so many different things that are building up this architecture, and just I've been changing my mind quite a bit due to documentation. But it's going to be useful for future developers who come on board to understand what I was thinking and why we implemented some of these things. All right. So I stole this from Greg, but software architecture is a journey, not a destination. So just like a junior developer doesn't take a single course and immediately becomes a mid-level developer, software developers accrue skills and qualities over the years that help them make informed decisions to convince stakeholders of their vision, thus allowing them to fill more of an architecture role. Okay, so as you move up the architect ladder, breadth of knowledge becomes increasingly important. What I would say to that is, if you don't know all the possible solutions, or at least a few of them, how do you know that the one you chose is the most optimal for the business needs? So let me give 2 examples here, and then kind of get your feedback. But would you rather have someone with 20 years of .NET experience making a decision on the future design of a software system, or would you rather have someone with 20 years of general experience who's dabbled in numerous programming languages, frameworks, and technologies? So that answer, again, I would say depends, right? So if you're working at a Microsoft shop and you know that this is going to be a .NET project, you're going to want that Microsoft expert. You're going to want that .NET expert. But if a company is looking maybe to start a new project and try to find the best technological fit for whatever they're building, maybe you want someone who's more of a generalist, who's dabbled in a whole bunch of different technologies and would be able to make a well-informed decision based on their experience. I mean, any thoughts on that there?
I agree.
Okay, so the move towards software architecture involves improving soft skills, communication, mentoring, focusing on the bigger picture, along with technical skills. So learning a wide variety of technologies and patterns, as well as experience knowing which patterns to use and why. So this was not an exhaustive list of qualities that a software architect should have. I would really love some more feedback on what some other qualities you feel are vital to have in a software architect's tool belt. Also, I'd love to field any questions if anyone has any.
I've got a question. In your experience, in becoming a software architect, was there anything that surprised you? Or you didn't?
Yeah, it's a lot less. I mean, again, it's going to depend on the project that you're on, but in the project I'm on, it's a lot less coding and it's a lot more documenting and Visio, drawing out diagrams and really figuring out the architecture before you jump into any kind of coding. And in my mind, I was thinking, okay, this is going to take me a couple of weeks. I'll know what the design is going to look like and I'll be able to start coding. But it's 5 months later and we're still making design changes based on different requirements coming in. So it's not as straightforward as I thought it was going to be, quite frankly.
I want to add learnings with my new project as well. I learned that being an architect requires a lot of reading, especially if in terms of like specifications, OIDC, like identity management stuff, Scheme 2.0, like all of these are specs. And if we want to implement these things, there was a lot of reading involved that I did not expect I was going to do, because I was like, as a senior developer, like a lot more development, but now like really a lot of reading and making sure that we are compliant to all of these specs. So something I learned as well.
Yeah. Yeah, it's a lot of reading, a lot of documenting, less coding, unfortunately, at least at this point.
To Diane's point, is the architect responsible if somebody on the project stores sensitive data in clear text in the database or on the file system?
I would say yes.
Yeah. So
because the architect's been tasked with setting up those parameters up front. Hey, you shouldn't be storing plain text in the database and linters and whatever else, but that should all be set up front, I would think.
Right. So to Diane's point, you have to understand the laws around privacy, the laws around security, credit card rules and regulations. So it's a lot of knowledge and learning about things that most developers don't necessarily have to really worry as much about.
Yeah. And we touched on it a little bit before, but if there's a security breach, the architect needs to know what to do. As far as filling out certain forms, letting the correct people know what happened and making sure that it doesn't happen again. That's not in the back of the mind of a developer. They're just like, oh, let me fix this right away.
Yeah, what I always say when I had architects on my team is the difference between an architect and anyone else is you can never say it's not my fault.
Yeah.
An architect always says, the buck stops here, I'll figure it out. Other people point, oh, it's an API problem, or it's a database problem, or it's a network problem, or it's a security problem. But an architect has to know enough about everything to say, I'll figure it out.
Yeah, and I think that ties back into the breadth of knowledge versus depth of knowledge. Obviously, it's important to have depth of knowledge, but your breadth becomes extremely important the more you become a software architect. Any other comments? Any other questions from anyone?
Do you have any favorite books on software architecture?
Well, I've read a couple by, what's the gentleman's name? I think Eric Larson on domain-driven design. I've spent a lot of time reading probably every single thing on Martin Fowler's blog, which I think is an absolutely great resource for just getting a general sense of what it means to be an architect and understanding different patterns, understanding software process as well. But Martin Fowler's been a huge influence on this presentation as well as my career moving forward. But yeah, I would love some recommendations on specific books if anyone has any. Ed, do you have any specific any books you've read that you think are worth bringing up?
Domain-driven design I've skimmed. And what was the one I posted in the chat the other day? That's one I'm thinking about buying, the enterprise architecture. I'm sorry, enterprise design patterns, but not off the top of my head. I mean, I've also read Martin Fowler's blog. And then there's the design patterns book, but that's more software architecture. The other book I keep hearing about that I'm considering buying is the Google SRE book, the Site Reliability Engineer. It's kind of like the DevOps book, allegedly. So I think it paints a pretty good picture of how things are architected at Google and why they've architected them that way. Again, I've never read it, but it is very highly recommended on a lot of sites I frequent.
Okay, yeah, excellent. I haven't heard that one, so I'll need to take a look at that. Anybody else? Comments, questions, anything?
Great job, Don.
Thank you. No, I appreciate everyone. I mean, I feel like this was a great talk, and I feel like there was a lot of interaction with everyone. So really, thank you so much. Really appreciate it. All right, I will stop sharing.
Stop recording.